Factors affecting the resistance of a conductor. Okay, so now this resistance of a conductor depends upon four factors. Number one, if this is a conductor having a resistance R, then it is found that this resistance R, it depends upon the length of the conductor, which means this resistance, it is directly proportional to its length. Okay, if I have two conductors of the same material, one is of length 1 meter, another conductor which is of same thickness but the length is 2 meter. Now out of these two conductors A and B, okay, because we see that this conductor B has got more length, so therefore the resistance of this conductor B will be more than the resistance of conductor A. Alright, so smaller the length, smaller will be the resistance, larger the length, larger will be the resistance of a conductor. So that is the meaning of this factor. Okay, the second factor that the resistance of a conductor depends is, upon the area of cross section, and it has been found that this resistance R, it is inversely proportional to the area of cross section. So that means if I have two conductors of the same material, one is a thin conductor, another is, this is a thin conductor, this is a thick conductor. So it is clearly seen here that this area of cross section, it is smaller than this area. Okay, so therefore the resistance of this conductor will be more than the resistance of this conductor, because the area is small. So when the area is small, resistance is large, and when the area is large, resistance is small. So from here, right, we can say that if you have two conductors of the same material, one is thick, another is thin, so please remember that the thin conductor will be having more resistance. Okay, the third factor is this resistance depends on the nature of the material. That means, because conductors are of different types, you have silver, you have copper, you have aluminum, you have, right, so many conductors are available on earth. So but these conductors, they have different conductivity. So therefore, right, we say that this resistance also depends upon the nature of the material. What type of material are you taking, so that, right, accordingly we can have the resistance. So the best conductor among metal, it is silver. Okay, whereas why? Because silver has got the smallest resistivity or smallest resistance, so that is why the resistance of silver is is smallest. So silver is a good conductor of electricity. The fourth point is that this resistance, it depends on temperature. So that means when the temperature of a conductor is high, the resistance also will be high, and when the temperature is low, the resistance will be low. Okay, so these are about the factors which affects the resistance of a conductor. Okay, now combining these two, equation 1 and equation 2, or the first two factors, when you combine the first two factors, then you will get R is directly proportional to the length, inversely proportional to the area, or R here is equals to some constant, and the constant is rho L by A. Okay, so this rho, it is a constant of proportionality, and it is called the specific resistance, or sometimes we call resistivity of the material of a conductor. Okay, now let me name this as equation 1. So from this equation 1, let us define about the specific resistance or resistivity. Now from equation 1, if I substitute the length of the conductor to be 1 unit, the area of cross section also to be 1 unit, then what will happen to R? R is equals to rho. Instead of L you write 1, instead of A you write 1, so R is equals to rho. So what does it mean? It means that this resistivity of a conductor, it is numerically equals to the resistance of a conductor of unit length and unit area of cross section. So that is the definitions of resistivity. Right? Okay, if I'm saying that the resistivity of, let's say the resistivity of silver, okay, let's say it is 2.1 into 10 to the power, let's say 8. Okay, I'll explain this in the next video. Okay, so till here I'll stop.